Today we are learning partial fractions, which is a really weird topic, and you're not going to understand why we do this, but I'm going to help you understand how it works and then do my best to promise you that it is very, very useful in the future. So you're never going to use partial fractions to solve anything other than just a partial fractions problem. So let's say I had 1/2 plus 2/3. In order to add fractions, I need to have a common denominator. So in this case, the common denominator is going to be 6. So this side needs a 3 over 3, and this side needs a 2 over 2, and we end up with 3 over 6 plus 4 over 6, which gives me 7 over 6. Okay, you've been doing that since, what, 4th grade? Something like that. But you've never gone backwards. Okay? If we start with the number 7 over 6, and I told you this fraction was created by adding other fractions together, can you figure out what fractions those were? Well, we need to look at 6. So 6 has prime factors 2 and 3. Now, how many fractions can we add together to get 7 over 6? An infinite number, right? So there are an infinite number of ways to do this. So we need to set some rules. The rules are every single fraction on the left side has been simplified. Okay? So every fraction on the left side is simplified. That's one of our rules. The other rule is none of the fractions on the left side are whole numbers. Okay? And when we do that, it actually eliminates almost all of the possibilities. Okay? So, because 6 has 2 and 3 as factors, then I know that the possible fractions that created 7 over 6 are something over 2 plus something over 3. How do I know that it's not something over, say, 8? How do I know that's not one of them? 8 does not go into 6. But what if it was, let's say, let's say it was like 12 over, and that's a bad example. What if it was, whatever, we'll just do 12. How do I know it's not 12 over 8? Because that would simplify to have a 2 on the bottom. So how can I guarantee that 12 over 8 wasn't one of the original answers? Because I said all of the original fractions were simplified. So this can't happen. All right, so let's work backwards. What could have happened? Something over 2 plus something over 3. So to figure out what the answers are, I'm just going to put in A and B. Okay? Well, what does the first fraction need in order to get this denominator? It needs a 3. So this will be 3 over 3, and this will be 2 over 2. So now I have the equation 3a plus 2b over 6 is equal to 7 over 6. Well, now I don't need the 6 anymore. I can just multiply both sides by 6 or just delete the 6. And I get 3a plus 2b equals 7. So now how do I solve this? Okay, well, it's a little tricky to solve this because I have one equation and two variables, right? But I know that A does not have 2 as a factor. Looking over here, A does not have 2 as a factor. Otherwise, it would have simplified, and that was against the rules. So B does not have 3 as a factor. And so I could kind of play with numbers. And can you think of a way to make a 7 with a 3 and a 2? How could you make 7 with a 3 and a 2? So you could do 1, 3, and a pair of 2s. That would make 7. Okay, are there any other numbers that would work? Let's try, if I times this by 3, so 3 times 3 is 9. And then if B was -1, that would be 7. So it turns out there are multiple ways to figure this out. Okay? But I can reverse engineer the fraction 7 over 6, and I can find two fractions that add together to be 7 over 6. And those fractions are simplified fractions. Okay? Well, let's make this a little more complicated. And these are impossible to make up on the fly, so you've got to steal them from a book. All right, so partial fractions. Way back here. Oh, matrix, determinants. There we go. Okay. So we're going to start with something easy. We're going to start with 7x minus 1 over x squared minus 2x minus 3. Okay? This rational expression was created using fractions, and those fractions were in simplest form. So what could those fractions have been? Well, when we factor the bottom, we get x squared, we get x minus 3 and x plus 1, right? So the fractions that could exist would be something over x minus 3 plus something over x plus 1. And I don't know what those somethings are, so I'm just going to call them A and B. And then that's equal to 7x plus 1 over x squared minus 2x minus 3. All right. Well, let's get rid of the denominators. So this side needs an x plus 1, and this side needs an x minus 3. And then, of course, x plus 1 and x minus 3. Now all the denominators match, so I'm just going to drop them. And I get this equation, ax plus a plus bx minus 3b is equal to 7x plus 1. Everybody understand? So this contains, it's one equation, but it contains lots of variables. And when I did the number version, there were a lot of correct answers, right? Because I had one equation with two variables. Well, this equation is actually two independent equations. So this and this and this interact with each other, but they don't interact with the other numbers. Interact is the wrong word, right? We know that ax plus bx has to be 7x. So I'm going to kind of siphon those out, and I get ax plus bx equals 7x. And then I have another equation that doesn't have any x's. So a minus 3b is equal to 1. And then we're sort of stuck. right? We have one equation that has 3 variables and one equation that has 2 variables. What should we do? Well, let's divide the top one by x, right? Every term has an x, which means the x is not needed. So I'm just going to go through and get rid of those. And that little trick right there leaves me with a linear system with 2 variables. So I'm going to times this one by -1, add, and I get 4b equals -6. Divide by 4, b is -1.5. Does that make sense? So if, what's that? So I could do elimination. So the a's would cancel. You could do substitution. You could times the top by 3. You could times the top by -1. I just picked one so that the a's would cancel. So b is 1.5, or -1.5. So if b is -1.5, then a has to be 8.5. So going back over here, 8.5 over x minus 3 plus -1.5 over x plus 1. Those are the 2 fractions that were used to create that fraction. Oh, it's +6. Thank you. Thank you. Okay. So 6, so +1.5, and that means it's not 8.5, it's 4.5. Who knows? Maybe there's another mistake in there too. But so what I've done, we spent weeks learning how to take rational expressions and crunch them together to create one expression. And now we're pulling those apart. And you might say, why? Why would you want to pull that apart? Well, when you get to calculus, which is the holy grail of mathematics, calculus is unbelievable. It's so simple. And the fact that it works just blows your mind. Well, calculus on this is really complicated. And calculus is not tough, but the algebra and the trig of calculus is what makes it hard. Calculus itself is pretty easy, but calculus on something that complicated is a lot of work. So you could work it out using that equation. It's just a huge pain. And it turns out it is way easier to do calculus on these. So trying to solve this the normal way takes forever. And converting it from this to this is a little bit of a pain, but not too bad. And then calculus on this and this is super easy. So if you can break the equation apart, it makes differentiating and integrating so much easier. Okay, so let's do another one. Yeah, sure. How did you do it? Let's do another one. So 5x plus 13 over x squared plus 4x minus 5. So my factors are x minus 5 plus 5 and x minus 1. So a over x plus 5, b over x minus 1, and that's equal to 5x plus 13 over x plus 5 and x minus 1. So this one needs an x minus 1, and this one needs an x plus 5. And that gives me ax minus a plus bx plus 5b is equal to 5x plus 13. So now I need to make an A equation, or an X equation and a non-X equation. So the X equation is A plus B equals 5. I'm not even going to bother writing the X's down, because all I'm going to do is delete them. And then my other equation is negative A plus 5B equals 13. This is already set up for elimination. So A's cancel, and I get 6B equals 18. So B is 3. And if B is 3, then A must be 2. So I come over here, and I get 2 and 3. Okay? Now, those are the easy ones. Let's go back to our original example. And let's say I had the fraction 7 over 12. Okay. So 7 over 12 is 2 times 2 times 3. And so I'm going to change this to 2 squared times 3. What fractions were used to create the 7 over 12? And this is where it gets a little bit tricky. So we know we have to have A over 2. We also have to have B over 3. Okay? But whenever a factor shows up more than once, then the highest power of that factor must also be included. So we also need a C over 2 squared. Okay? All right. Let's say we had, let's do 72. So let's say I had 53 over 72. Okay? 72 is 2 to the third times 3 squared. So what are my fractions? Well, I need a 2, so A over 2. I need a 3, so B over 3. And then I need the largest power of 2. So C over 2 to the third. And the largest power of 3. So D over 3 squared. Can you guys remember that? So anytime a factor is duplicated, you need the original factor, and you need that factor in its largest form. You don't need, like, we don't need a 2 squared. Oh, yeah. We don't need a 2 squared. We just need a 2 to the third. Okay? Now that's important. Okay. So negative 3x squared plus 13x minus 12 over x to the third minus 4x squared plus 4x. Okay. I pull out an x, and I get x squared minus 4x plus 4. Two numbers that multiply to be 4 that add to be negative 4 would be negative 2 and negative 2. So I get this. So what will my partial fractions be? A over x and B over x minus 2 and C over x minus 2 squared. Okay? Same process. This needs an x squared. Well, this needs an x and an x minus 2. Right? This one needs an x. This one needs x minus 2 times x minus 2, which is x squared minus 4x plus 4. Does everybody understand that? Everybody good? So we get ax squared minus 4xa plus 4a, plus bx squared minus 2bx plus cx is equal to negative 3x squared plus 13x minus 12. Right, I need an x squared equation, I need an x equation, and I need a constant equation. So my x squared equation will be a plus b equals negative 3. So a plus b equals negative 3. My x equation is negative 4a minus 2b equals 13. Oh, thank you. Plus c. Good call. This one. Okay, and then my constant equation is 4a equals negative 12. Yeah, these are actually really easy to solve because you will almost always have a single variable. So we know that a is negative 3. So if a is negative 3, then b must be 0. And if b is 0 and a is negative 3, then c must be 1. So that original fraction was made by taking negative 3x and adding it to 1 over x minus 2 squared. Okay. When do we get out of here? Oh, sweet. We're rocking it. All right. Next step. Seven x squared plus 2 over 2x plus 1 and x squared plus 1. Now, x squared plus 1 does not factor. It does factor into imaginary numbers. So we took the original x to the third in the denominator and we factored it. We got 2x plus 1. We got x squared plus 1. X squared plus 1 cannot be factored further using real numbers. But when we do a over 2x plus 1 and then something over x squared plus 1, for reasons that are hard to understand, no, it's not that hard. If I took 45 and I divided it by 6, I'm going to get 7 remainder 3, right? If I had a really big number and I divided it by 6 and I told you that the answer was 847 remainder 7, what are you going to tell me? Yeah, I messed up, right? 6 can go into that number one more time. So I would need to change this to an 8 and then put a 1 there. So the remainder is always smaller than the number you're dividing by. Okay? Well, when you add rational expressions together, then the bottom is an equation and it's a polynomial. The degree of the bottom will always outpace the degree of the numerator. So if your denominator is linear, then your numerator has to be constant. If your denominator is quadratic, then your numerator could be linear. So if your denominator is an x squared, then the top could look like mx plus b. So we end up doing cx plus d. And we didn't have to do that over here because the degree of the bottom is 1, and so 1x smaller than linear is constant. What if the bottom was x to the third plus 3? What would your numerator have to be? It would be ex squared plus dx plus, no, I don't know my alphabet, but whatever. So anytime one of your factors is quadratic, then the variables above it need to be linear. So the equation on the bottom essentially has to have one more x than the equation on the top. If the bottom is linear, then you don't need any x's on top. Okay, and then we do the same process. So this needs an x squared plus 1, and this needs a 2x plus 1. So we get ax squared plus a, and then plus 2cx squared plus cx plus 2dx plus d. And that's all equal to this. So I siphon out my x squareds. So a plus c equals 7. 2c, thank you. And my x's, 2dx. I really fouled my alphabet up, didn't I? Whatever. 2dx plus c is 0. And then a plus d is 2. Did I? Oh, I put an x in there. I didn't need to. Did I do that right? So a and d, c and 2d, and a and 2c is 7. So this is kind of annoying. Let's times this by -1. So negative, 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 and then we'll add those together. A's cancel, and we get d minus 2c equals 5. Negative d, thank you. And now we can put these two together. So I times the bottom by 2. So that would be a 2, and that would be a 4, and that would be a 10. That's not going to happen to you on the test. But anyway, we end up with yeah. So we end up with c is 2. So once you get c equals 2, then you plug it in here and you find out that d must be 1 or -1. So d is -1, and then you find out that a must be 3. But the system of equations was a little complicated on this, but that's not going to happen to you on the test. Okay? All right. One more thing you need to know. No. Okay, we're going to go back to here because it doesn't happen in the book. All right. So in this case, we follow all the rules, but notice this is a top-heavy fraction. So if I asked you, do a partial fraction decomposition on the fraction 11 over 7. Okay? Well, 11 over 7 can be changed to 1 and 4/7. And then we find the fractions that created 4 over 7. So if the fraction is top heavy, then we need to convert it to a mixed number, and then we will just do partial fraction decomposition on the mixed number. How do you turn a rational expression from a mixed number, from a top heavy fraction to a mixed number? Well, how do you turn 11 over 7 into a mixed number? You do 11, I don't know, my goodness, I don't know how to do math. So how many times does 7 go into 11? Well, one time. 1 times 7 is 7. Then we get 4. So it's 1, remainder 4. So plus 4 over 7. So we just need to do division. So I draw the box. X to the third plus 2x squared plus 0x plus 0. Okay. I stick in negative. What? Because I don't know what I'm doing. Isn't it amazing I graduated from college 3 different times? I don't know how I made it. All right. X to the third goes into negative 4x to the third, negative 4 times. So negative 4 gives me this, and then 0x and 0. Add a column. These need to add up to negative 7. Oh, I did it wrong. 4, 3, 2, 1. There we go. So those need to add up to negative 7. So negative 3x to the third. Pull out an x to the third, I get minus 3. Negative 3 times x squared is negative 3x squared. And then 0x squared and 0x. Okay. Now these three, so that's my remainder line, right? Once you hit the constant, that's your remainder line. These three need to add up to negative 1. So I have negative 3, I need negative 1. What should I add? 2x squared. Everybody get that? Okay. These three need to add up to 6x. I don't have anything, so I need a 6x. And then these two must add up to 3, so plus 3. So my mixed number is negative 4x minus 3 plus, this is my remainder, 2x squared plus 6x plus 3 over x to the third plus x squared. Yes. So I have now created an equation that I can do partial fractions on. So we're just going to remember this. So negative 4x minus 3. Oh, did you need it? Oh, cool. So that negative 4x minus 3 is part of my answer. But I can just leave it aside. That's the whole number, essentially. Now I need to decompose the fraction. So the fraction is x squared times x plus 1. Right? So how many partial fractions do I need? 3. I need a over x. I also need b over x plus 1. And I also need c over x squared. Now, does it need to be cx plus d? No, because the factor is x. The squared is a duplicate of x. If it was, say, x squared plus 7, then I would have to do cx plus d. So this is over x squared. So this one needs an x and an x plus 1. So x squared plus x. This one needs an x squared. And this one needs an x plus 1. Okay? So this gets long. Ax squared plus ax plus bx squared plus cx plus c is equal to that. So a plus b equals 2. A plus c equals 6. And c equals 3. So c is 3. And if c is 3, then a is also 3. And if a is 3, then b is negative 1. So this is the partial fraction for the remainder, essentially. So I need to bring in this again. So it's negative 4x plus 3 plus all of that. Yes. So it's long, but it's not difficult. You want to do another one? No? Oh, if you don't want to, don't pay attention. But let me, so I have to go out and go back in to get a new problem, right? Okay. So we want number 5. Number 5 is top heavy again. So I need to do division. X squared minus 3x minus 4. And negative 5x to the third. So negative 5x plus 15x squared, 20x. And these need to add up to 20, so I need another 5x. So plus 5. That gives me negative 15x and negative 20. So my remainder is going to be 20 minus 15 is 5. I need a 7, so that's plus 2x. And negative 20, I need a negative 3. So I'm going to put a 17. So negative 5x plus 5, and then my remainder is 2x plus 17 over x minus 4 and x plus 1. Yep, this is just a and b. So a over x minus 4, b over x plus 1. So this needs an x plus 1, and this needs an x minus 4. And ax plus a, bx minus 4b is equal to that. So a plus b is 2, and a minus 4b is 17. So I'm going to negate the bottom and add. The a's cancel, and I get 5b equals negative 15. So b is negative 3. And if b is negative 3, then a must be 5. So 5 over x minus 4 plus negative 3 over x plus 1. And I'm going to double check and see how they want us to put this. It seems like I remember if you... So I'll try it and see. But don't forget to put this on there too. So I think there's a little bit of a formatting error. And if you get it wrong, I can change your score on this one. Well, I'm just going to I'm just going to click check answer and see what it wants me to say. Okay, so it wants you to put the negative up top. If you put the negative here, that is correct, but I think it will mark it wrong. So make sure any negatives stay up there.